Hi, I am Syed on Maths Online. In the previous video, we have discussed about one of the property Laplace transform of e power of at f of t is nothing but f bar of s minus of a. Today we'll deal with the second property. So let me give the second property. If Laplace transform of f of t can be written in the form of f bar of s, then Laplace transform of t power of n into f of t is nothing but minus 1 power of n d power of n by ds power of n into f bar of s. That's the property we have. So let us take few examples based on this property. So let us take the first example. So question number 1, we have to find the Laplace transform of t cos 2t. So let us try to find out the Laplace transform of t cos 2t. So if you try to compare this with this particular result over here, it is t power of n into f of t form. So first let me find out f bar of s by taking f of t. So let us take f of t to be equals to, say, cos of 2t. Then find out the Laplace transform of this. It is Laplace transform of f of t is equals to, it is Laplace transform of cos of 2t. And we know the Laplace transform of cos 2t is nothing but s by s square plus a square. So here a value is 2, so 2 square. So which is nothing but, it is s by s square plus 4. And this is considered as f bar of s, because this L of f of t over here can be written in the form of f bar of s. So we got f bar of s. Now once I have got the value of f of t, I have to introduce this t value, t power of n. So here I have to introduce this t value over here. So if I introduce the value of t there, then in that case we have to apply the formula. So this can be further written in the form of, it is Laplace transform of, it is t f of t. So if I introduce this t into f of t, the formula that we have is minus 1 power of n. So what is the value of n over here? T power of 1 is there. So the value of n is 1. So t power of 1. I'm just using this formula that I have given you over here. So this particular formula. So it is minus 1 power of n value. So n value is 1 over here. It is d by ds. So d power of n, d power of n value is 1 divided by ds power of n value is 1. So it's a first order derivative times of, you are having f bar of s. Or further, if I try to rewrite it, Laplace transform of t into, we know the value of f of t. F of t I have taken it as cos 2t, which is minus of, it is d by ds of, I have got the value of f bar of s over here. So the value of f bar of s is s by s square plus 4. Now it is d by ds, which means that I need to differentiate the given expression s by s square plus 4 with respect to s. So therefore, keeping this negative sign as it is, now this is in the form of the quotient rule. It is d by ds of, it is u by v form. So here you are differentiating with respect to s. So your normal formula is v into u dash minus u into v dash divided by v square. So this is general formula that you have. So let us use this formula over here. So if you use, it is v value is the denominator value, s square plus 4. S square plus 4 into u dash. U dash value is differentiation of s with respect to s will be 1 minus u. U value is s into v dash. That means differentiation of the denominator. S square differentiation will be 2s plus the constant differentiation is 0. Whole divided by it is v square. That means the denominator square. S square plus 4 whole square. So we have done the differentiation of s by s square plus 4. So now let us try to simplify this expression, which will be equals to, it is minus of, this is s square plus 4 into 1 will be s square plus 4 itself, s square plus 4 minus, you multiply this s with 2s, you will be getting 2s square. The denominator value that you have is s square plus 4 whole square. So write down that expression in the form of s square plus 4 whole square as it is. S square plus 4 whole square. Or further, if you try to simplify, it is minus of, you can see this is 4 as it is, the constant. You are having s square minus of 2s square will be minus s square. It is whole divided by, you have s square plus 4 whole square. Or if you try to multiply that negative sign inside, so in that case you will be getting the value to be equals to, so minus of 4 it becomes, and minus of minus plus s square. So first I will write the positive value s square, then minus of 4, it is whole divided by, you have s square plus 4 whole square. That is the required solution that we have. So let us move on to the next question. Question number 2. So find the Laplace transform of t square into sine of 3t. T square into sine of 3t. So I'll just try to follow the same procedure what I have done in the previous example. It is in the form of t power of n into f of t. So first I'll take the value of f of t. So let f of t be equals to, it is sine of 3t. So find out the Laplace transform of this one. Laplace transform of f of t is nothing but the Laplace transform of sine 3t. So we know the Laplace transform of sine at, which is a by s square plus a square. So in this case the value of a is 3. So it is 3 by s square plus a square. S square plus 3 square. Or further, if you try to simplify this one, it is 3 by s square plus 3 square will be 9. So you can take this expression to be equals to f bar of s. So once you got the value of f bar of s, then you can go ahead with the formula. So for that you have to introduce the value of t over here. So it was only f of t. Now along with that you have to introduce this t square. So this t square times of f of t. And the general formula that you have is minus 1 power of n. So what is the value of n in this case? The value of n is 2. So minus 1 whole square d square by ds square times of f bar of s. That is the formula you have. Minus 1 power of n d power of n by ds power of n into f bar of s. We know the value of f bar of s, just try to plug in over there. And simultaneously this minus 1 whole square will be positive itself. So that becomes positive. You have d square by ds square of f bar of s. So your f bar of s is nothing but 3 by s square plus 9. So we need to differentiate this expression over here. Because it is of second order, you have to differentiate it twice. So 3 is a constant, I can take 3 outside, it becomes d by ds of. You can rewrite this in the form of d by ds of 1 by s square plus 9. So just for convenience, I have written in this form. D square by ds square can be written as d by ds of d by ds. Now let us try to differentiate this one. 3 times of, it is d by ds of. So I have to differentiate this with respect to s because it is in the form of 1 by x. differentiation of 1 by x will be minus 1 by x square. That's the basic differentiation formula that you have, d by dx of 1 by x. We know this formula. It is minus 1 by x square. Into this differentiation of x will be 1 itself. So you have got differentiation of 1 by x is minus 1 by x square. So following the same formula, you can write this as minus of 1 by s square plus 9 whole square. So it is 1 by x differentiation is minus 1 by x square. Now here inner differentiation formula, s square plus 9 differentiation. S square differentiation is 2s. 9, the constant differentiation will be 0. So once the value is being differentiated. So further, if I take this negative sign outside along with this 2. So 2 times of 3 will become 6. You will be getting d by ds of, you have the expression as s by s square plus 9 whole square. S square plus 9 whole square. So once again we need to differentiate this expression. Now because here s you have both in the numerator as well as in the denominator, so therefore I will be using the formula u by v form. So in the previous example we have used the formula d by ds of u by v form. So let us use the same formula over here. So the numerator value is your u value, the denominator value is your v value. So the formula is v into u dash. So v value over here is s square plus 9 whole square. V into u dash, differentiation of s with respect to s will be 1 minus u value is s into differentiation of v dash. So first power differentiation has to be done. It is 2 times of s square plus 9 into inner differentiation. S square differentiation will be 2s, 9 differentiation will be 0. So it is v into u dash minus u into v dash whole divided by v square. So if you try to write down, it is v value is s square plus 9 whole square and it is v square. So further you have to square this value. So we have squared this value. So let us try to simplify this expression further. So we will be getting the value to be equals to, it is minus 6 times of. So if you try to observe here in both the terms, s square plus 9 is common. So I will be taking s square plus 9 to be common. So if you take s square plus 9 as common, from the first term, once s square plus 9 is taken common outside, one more s square plus 9 will be left out there. Then you have a negative sign over here. You can write down the negative sign. It is minus of. Now because this s square plus 9 is already taken common outside, what is left out? This 2s is left out and this 2s is left out. So 2s into 2s will become 4s square, right? And whole divided by the denominator value that we have is s square plus 9. It is whole power of. So square of square. So 2 times of 2 will become power 4. Now if you try to observe, you can cancel out this s square plus 9 once and s square plus 9 once. So in the denominator you will be left out with s square plus 9 whole cube. That is equals to minus 6 times of. So you will be left out with 9 minus 4s square plus s square will be minus of 3s square. Is divided by s square plus 9 to the power of 3. Because 1 s square plus 9 has been cancelled out, therefore you are left out with s square plus 9 whole cube. That's the required solution. Find Laplace transform of t cube into sine of t. So first we have to take the value of f of t. We will take the value of f of t to be equals to sine of t. Apply the Laplace transform on both the sides. So Laplace transform of f of t is Laplace transform of sine of t. So we know the formula of sine at. It is a value in this case, coefficient of t is 1. So a value is 1 here. It is 1 by s square plus a square. A square is 1 square, which is 1. So this will be acting as your f bar of s. Now over here I have to include the t value from the question. It becomes t cube into f of t. T cube into f of t, the formula will be minus 1 power of n. So what's the value of n in this case? N value is 3. So you'll be getting d cube by ds cube times of f bar of s. So we know the value of f bar of s over here. You need to just plug in that value. So minus 1 whole cube, whenever you have odd power, negative sign will come outside. And you have, it is d cube by ds cube times of f bar of s. F bar of s is 1 by s square plus 1. So further, if you try to simplify this expression, you need to differentiate this thrice, 3 times. So d square by ds square twice. If you are going for the differentiation for the first time, you will be getting d by ds of. So this expression, it is d by ds of, you have 1 by s square plus 1. So you have to differentiate this one. So if you try to differentiate it, keeping this d square by ds square as it is, because you have in the numerator a constant value, you can go ahead with the formula. D by dx of 1 by x will be minus 1 by x square. So it is minus 1 by s square plus 1 whole square into the inner differentiation. Inner differentiation of s square will be 2s plus the constant differentiation 1 will be 0. So once the differentiation is complete, it will be equals to, now you can just multiply. It is minus of minus will become plus d square by ds square of, it is 2s by s square plus 1 whole square. S square plus 1 whole square. Or if I want to differentiate it once again, d by ds of, because s is there both in the numerator and denominator, you can go ahead and use the quotient rule. So v times of, that is s square plus 1 whole square, v into u dash. Differentiation of 2s will be 2 minus u value is 2s into v dash. So differentiation of this square term, so 2 times of s square plus 1 into the inner differentiation s square plus 1 will be 2s. Alright, so that's the differentiation of v, whole divided by, it is v square. So v square will be s square plus 1 whole square is your v value. Further you have to square, it is v square. So we got this expression. If you try to see in the numerator s square plus 1 is common. So you can take that common value outside. So it is d by ds of s square plus 1 is common. So if you take s square plus 1 common outside, here you have 2 times of s square plus 1. Whole square was there, because taken s square plus 1 common outside, one more s square plus 1 will be left out inside, minus. Because you have already taken this s square plus 1 outside, you are left out with the 2s into 2 into 2s. So you have 8 times of s square, whole divided by the denominator value s square plus 1, it is square of square will become power 4. Now you see that s square plus 1 over here will cancel out, and you will be left out with d by ds of, you just multiply this one, it's 2 times of s will be 2s square, alright, it is 2s square, plus you multiply the 2 times of 1 over here, it will be 2 minus of 8 s square, that is the numerator value. So if you try to simplify, 2 will be as it is, it's 2s square minus of 8s square will be 6s square. You can simplify and write down over here, it is 2 minus of 6s square whole divided by, because s square plus 1 has been cancelled out in the numerator as well as in the denominator, you are left out with whole cube over here. Now further you have to differentiate it. Once again using u by v rule, it is v into, that is s square plus 1 whole cube, it is v into u dash So differentiation of the 2 is 0. 6s square differentiation will be 12 times of s. It is minus of u value, that is 2 minus of 6s square into v dash. So cube differentiation will be 3 times of s square plus 1 whole square into inner differentiation, s square differentiation will be 2s plus 1 differentiation will be 0. It is whole divided by the denominator square. So the denominator over here is s square plus 1 whole cube and its square v square. Further we'll try to simplify over here. If you try to observe once again over here in the numerator, you can take the common value. So common value, if you try to observe, s square plus 1, what is the lowest power you have? Lowest power you have is square. So I can take s square plus 1 whole square common outside. So now you'll be left out with minus of 12s. Because cube was there, square I have taken outside. One more s square plus 1 will be left out over here. Minus of, because s square plus 1 whole square is already taken outside, you are left out only with 2 minus of 6s square multiplied by this 3 times of 2 will be 6s. It is whole divided by the denominator value that you have is s square plus 1 whole power of, just multiply 3 times of 2 will become 6 over here, power 6. But in the numerator you have power 2 and in the denominator you have power 6. So if I take that power 2 in the denominator, it becomes 6, power 6 minus of 2 will become 4. So it becomes power 4 there. So you have in the denominator s square plus 1 whole power of 4, because the s square plus 1 whole square has come in the denominator. Now let us try to simplify the numerator value. It is minus 12. We multiply s into s square will be s cube. So plus into minus will be minus, 12s into 1 will be 12s. Then minus of, we multiply the 6s with 2 will be 12s. Then minus of minus will become plus, 6 times of 6 will be 36 s cube. That's the expression you have. Now further let us try to simplify this expression. This will be equals to, so like terms you can add or subtract. It is 36 minus of 12. Alright, if you just try to subtract that value, you will be getting 24 s cube. Then minus of, you have 12s, 12s will be 24 s. It is whole divided by the denominator as it is, that is s square plus 1 whole power of 4. Further, if you try to observe over here in the numerator, I can take 24s common outside. So you will be left out inside with a square value over here and minus 1 value. It is whole divided by the denominator as it is, that is s square plus 1 whole power of 4. Alright. Now if I try to rewrite on the side, it is t cube, and your value of f of t, you know its value that I have taken is sin t. Hence we got the value of Laplace transform of t cube sin t to be so much. So that's the required solution. Let's move on to the next question. Find Laplace transform of t power of 5 e power of 4t cos h 3t, cos h 3t. So we try to observe this example. It is t power of n into this entire expression will be acting as your f of t value. But once again, because you are having hyperbolic function there, so you can convert this hyperbolic function in the form of the exponential function, just using the formula for cos h at. So let us use that formula over here. So you are having, this is t power of 5 into e power of 4t into cos h 3t. Right, this will be equals to, so keeping this t power of 5 and e power of 4t as it is. So I'll use the formula for cos h at. Cos h at, as we know, its formula is nothing but e power of at plus e power of minus of at whole divided by 2. So if we use this formula over here, so it will be e power of a value in this case is 3. So e power of 3t plus e power of minus of 3t, it is whole divided by 2. So taking that divided by 2 common outside, it becomes 1 by 2, it is t power of 5. Now just try to multiply this e power of 4t with e power of 3t. So you will be getting the value to be e power of, and the bases are the same, you can just add the powers. 4 plus 3, it will be 7t. Then plus it is e power of, if 4t minus of 3t will be just t. So we got this expression. So which is nothing but it is half times of the expression that you have is half times of, it is e power of 7t into t power of 5. It is plus, it is e power of t into t power of 5. Now you can go ahead and use the same formula what I have used in the previous problem, but because the power is very high, it is t power of 5, which means you have to differentiate it for 5 times. You have seen in the earlier example, when the power of t was 1, you have differentiated once. When the power of t, if it is 2, then you have to differentiate twice. In the previous example over here, the power of t was, you have differentiated thrice. So the problem becomes very lengthy. Here, because it is t power of 5, you have to differentiate 5 times. It becomes very lengthy. So if you want, you can try with that previous method, or the other method that we can follow is, I have given you in the previous video this formula, Laplace transform of e power of at f of t is nothing but f bar of s minus of a, the shifting rule. So you can go ahead and use this shifting rule over here. So if you try to use that formula over here, I'll be getting 1 by 2 times of. So if you want to do it directly, this e power of a will be shifted to this s minus of a. That means s will be shifted to s minus of a. The only thing that you have to do is you need to just find out the value of L of f of t, which is nothing but here f bar of s. Once you get this f bar of s, you have to shift this s value to s minus of a, which means that I need to only find out the Laplace transform of t power of 5. And we know that Laplace transform of t power of n, when n is an integer, is written as n factorial divided by s power of n plus 1. So let us use the formula over here. So I am trying to find out the Laplace transform of this expression. So for that, I have to apply the Laplace transform. So Laplace transform of e power of 7t into t power of 5 plus Laplace transform of e power of t into t power of 5. Left hand side also you have to apply the Laplace transform of t power of 5 e power of 4t into cos h 3t. So now if I try to rewrite, it is 1 by 2 times of, which means I need to only find out the Laplace transform of t power of 5. So what will happen to this s value? S will be shifted to s minus a. So what is the value of a here? A value is 7. So s minus of 7. S will be shifted to s minus of 7 plus here also Laplace transform of, it is t power of 5. S will be shifted to s minus of a. So what is the coefficient of t over here? Coefficient of t is 1. So s will be shifted to s minus of 1. So in this way you can rewrite it. So what I have done, I have just to eliminate this e power of 7t, I have written the Laplace transform of t power of 5, and this e power of 7t is eliminated by writing s is being shifted to s minus of a. Here also same thing, s is being shifted to s minus of a, which will be equals to 1 by 2 times of n value over here is 5, so it is 5 factorial divided by s power of 5 plus 1. right? And what will happen to this s value over here? S is being shifted to s minus of 7 plus here also it is 5 factorial divided by s power of 5 plus 1. S is being shifted to s minus of 1, which is nothing but 1 by 2 times of. We know 5 factorial is 120 divided by it is s power of 6. S is being shifted to s minus of 7 plus you have here also it is 120 divided by s power of 6. S is being shifted to s minus of 1. Now just replace the value of s in the first term to be s minus of 7. We get the result to be equals to 1 by 2 as it is. It is 120 divided by s minus of 7 whole power of 6 plus 120 as it is whole divided by s is being shifted to s minus of 1 whole power of 6. So you can take that 120 common outside, is 1 by 2 times of it is 120, and write down this expression as it is 1 by s minus of 7 whole power of 6 plus it is 1 by s minus of 1 whole power of 6. But you can cancel out this 120 with 2. You will be getting the expression to be equals to 60 times of, right? So you will be getting 60 times of 1 by s minus of 7 whole power of 6 plus 1 by s minus of 1 whole power of 6. That's the required solution. Let us move on to the next question. Show that integral 0 to infinity is t e power of minus of 2t sine 4t dt is equals to 1 by 25. That is the result that we need to show. So for that, we'll go ahead with the basic formula of Laplace transform. So we know this result. So we know Laplace transform of f of t is equals to, it is integral 0 to infinity e power of minus st f of t into dt. Right, now if I try to compare this expression, which will be equals to, it is integral of 0 to infinity, it is e power of minus of st. So you have over here the value as it is t sine 4t. So that can be taken as your f of t value. However, this value that we have, that is e power of 2t, this expression that you have e power of 2t. So we'll just try to keep it as it is. Here also it is e power of st. I'll keep it as it is. I'll not be changing it. Though s value over here is your value of 2. So I'll try to replace that later on. As of now, I'll keep that value as it is. So just take the value of f of t to be equals to t sine 4t. So if you do that one, in that case, this f of t value will be nothing but it is t sine 4t into dt. So what I have taken? I have taken the value of, so let the value of f of t be equals to this t sine 4t I have taken, right? So therefore here also I'll try to replace the value of f of t. Its value is nothing but t sine 4t. I can find out this t sine 4t using the procedure that I have followed for the previous problems. So let us first try to find out this t sine 4t. So if I take sine 4t value and try to find out Laplace transform of sine 4t. So Laplace transform of sine 4t, if you use the formula, it is a by s square plus a square. So a value over here is 4 by s square plus a square, that is 4 square. So you will be getting 4 by s square plus 4 square value will be 16. So this will be acting as your f bar of s. So because I am using the procedure which I have done for the previous problem, in that case you have to introduce the value of t. So if you introduce t value over here, because t is over here, I will be introducing t itself. So t times of, you have sine 4t. So general formula that you have is minus 1 power of n. So because the power of t is 1 over here, so n value is 1. So minus 1 power of n value is 1, d power of n by ds power of n. So n value is 1 into what you have, f bar of s. So which will be equals to minus 1 power of 1 will be minus, it is d by ds of, your f bar of s value is over here. So which is nothing but 4 by s square plus 16. So if I try to simplify this expression, because 4 is a constant, I can take that 4 outside. So negative of 4 will be left out outside. D by ds of, it is 1 by s square plus 16. So now it is in the form of d by dx of 1 by x. Its derivative will be minus 1 by x square. So it is minus 1 by s square plus 16 whole square into the inner differentiation of s square plus 16. S square differentiation is 2s, 16 differentiation is 0. Or if you further try to simplify this expression, multiplying minus 4 inside, so minus of minus will become plus, positive 8s you will be getting, divided by what you have, s square plus 16 whole square. So that's the value of Laplace transform of, it is t sine 4t. So you need to plug in this value back there in this given expression. So you have that equation number 1. So equation number 1, left hand side value I have got it over here, is Laplace transform t sine 4t. So therefore your equation number 1 implies, so equation number 1 implies, so you have 8s divided by s square plus 16 whole square is nothing but, it is integral 0 to infinity e power of minus st. So f of t we have written it as t sine 4t into dt. Now try to observe this expression with the question that is given. So in the question, this is the value that you see in the question. That particular value is nothing but your 2. So it is e power of minus 2s. So what I will be doing now is, I will put the value of s to be equals to 2, so that I get the required solution. Put the value of s to be 2 on both the sides. So it is 8 times of 2, it is whole divided by, it is 2 square plus 16 whole square is equals to, it is integral of 0 to infinity e power of minus, s value is 2, so 2t into t sine 4t into dt. So let us try to simplify that left hand side value. So if you try to simplify the left hand side value, I will be getting the expression to be equals to the 16 there in the numerator divided by, it is 16 times of 4 will be 20, right? So 20 square will become 400. That will be equals to, it is integral 0 to infinity, it is e power of minus of 2t, it is t sine 4t into dt. Or if I want to write down the, first the integral 0 to infinity e power of minus of 2t, it is t sine 4t into dt will be equals to, you can just cancel out that expression. It is 16 times of, how many times it goes, 25. You can just check out the solution. Are you getting the value to be equals to 1 by 25, which is the required solution? Just verify, are you getting 1 by 25 as your final answer? That is what we wanted to show. That's all I have for today. Thank you.